So in this tutorial, I'll show you how to use linear discriminant analysis for dimensionalities reductions and also use it with the SVM classifier. So in this notebook, we're going to be using to predict the possibilities of the company bankruptcies in Taiwan from between 2099 to 2009. We're going to be using two approaches. The first approach is we're going to be using with SVC. The second approach we're going to be using the LDA with the SVC. First, we want to import some library. We're going to be using the times functions to measure how the two approach run. Also import the standard libraries for managing the dataset and some libraries to visualize our models. From the sklearn models, we'll be using the train test split to split our dataset into the trainings and the test set. We also be using the SVM classifier, and the sklearn is also have the discriminant analysis. From here, we just need to import our linear discriminant analysis, which is LDA. We also want to have some metrics to measure how well those two approaches run, one with the SVC, one with SVC and LDA as well. So let's input the ROC curve and the AUC. The dataset is a little bit imbalanced, so we need the ways to upsampling the data using the random oversampler to make the dataset a little bit more balanced. Okay, let's run this. It runs nicely. The dataset we'll be using is the company bankruptcy predictions from FedEx Soranio, and just import it, and it imported nicely. So now to want to import that to our models using the read SCV and plug in the path to that models. And now we want to separate the features that we will let our models to learn from. First, we need to remove the target, which is the label we will be predicting. We will be remove the feature, so we need to put the axis is 1. In here, we will get all the rows data, and we only use the first 15 features to speed up the process. For our labels, we will be using the one that we just dropped, which is the bankrupt or not, and add it here. So now from the X and Y, we can build our trainings and test set. And we will split it with the portions 20%, 0 and 2, like this. So if we print this out the value right here, we will see that count value. We see that the data is imbalanced. So the data of the companies that financially stable is much more than the bankrupt company. So we want a ways to even out these values so our models doesn't have any bias. We're gonna be using the random oversampler and using the experience sample. We will have this using the fit resample and put in the trainings and the target. And if we print it out, we will see that the data is balanced now. Okay, so the next one we will be implement the support vector classifier. We want to measure how it's run, so we need to add a times here. Of course, we also need times that it stopped running, like put them together, and we have the actual time it takes to run this model. So now we need to add some logic inside. So now we implement the SVC, the sklearn, and we want to get the probabilities, because later on we want to have the rocks and AUC. So it's important that we print out the probabilities, not the actual label. Now let's confit, use this on the resamples data, resample. This is the training, and we want to get some predictions. So what we want is to have the y-bread svm.predict probabilities and put in the test set. Now measures the false positive rate along with the true positive rate from this SVM model. We will not be using the threshold, so let's remove that and just call the rock curve and input the y test, which is the actual value. We're going to be comparing that with the predictions of our models. The reason we use number 1 right here is because in here it will output some value, like for example first one 0 and 4. So it means that this value is going to be equals to negative and equals to positive, and we can see that this is larger, so it means that this company, it will not go bankrupt. But the thing is, because we're using the false positive rate and true positive rate, we only cared about the positive value, which is this one. So we have a 1 still points to the positive values in here. And now we can have the rocks AUC, and now plug in the false positive rate and the true positive rate and let it run. I speed it up a little bit, and you can see the actual runtime here is almost 40 seconds. And let's try to use the SVC with the LDAs for dimensionality reductions and see if this value can be better or not. So we will be using this value. It's going to be almost the same, but going to be adding some value. So let's call our model SVM LDAs to distinguish that with the models above, and also call on this data. But first we want to apply dimensionalities reduction. First we call the LDA model, and the 15 features will be reduced into 1 features only in the new dimensions. When we're using it with the LDA, we can change this to different numbers as well, so it just needs to be less than 15. And now we will manipulate the dataset of the trained data. So let's call it fish transform to let the model learn and also manipulate the trained data. Because this is a classification, so we need both the features and the target. For the test data, we don't want to let the model fit, which is equals to trainings. We just need to transform the data into from 15 into 1 without training. And now most of the step below is gonna be almost the same. So we have these SVM models right here, but instead of working on the trained resample, it's going to be using these features which have undergone through the dimensionalities reductions. So it's for the target, it will be the same. And now for the predictions, we will be calling this on the new LD8. For this one, just change the name a little bit, and this is gonna stay the same, so we can calculate the AUC by inputting the false positive rate and a true positive rate. Also let it run. Right in here, when we call the predictions functions, we also need to use the LDA. The actual runtime, it takes about 17 seconds instead of the 30 seconds right here. So we can see that the actual runtime is faster when we reduce the dimensions. But what about the accuracy? So now we can visualize the route AUC by calling the plot functions on both the true positive rate and false positive rate of the SVM. Now add some label. Now we're plotting the values from the SVM with the LDA, like this with LDAs, and we also print out the AUC. This will actually replace the values right here. And now we also plot the random classifier from the bottom left corner into the top right corner and specify it with a line style like dash 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 to separate it with our two models right here. And now we want to show the label like this and this in the lower right corner, and now we show that a comma, and we see that the model SVM, it doesn't work very well because because of dimensions. So with the 15 features, our SVM classifier is not performing the same as the random classifier, which is not a good thing. For the SVM with the dimensionality through the LDA, you can see that the actual result is increased to 0.88